All right, let's jump straight into it. Welcome to this explainer. Today, we're building your ultimate revision toolkit for GCSE Psychology Paper 2. Whether you're taking on the Edexcel syllabus or another board, research methods are literally the engine room of your final grade. The source material we're breaking down today doesn't just throw definitions at you, it builds a highly strategic toolkit so you can tackle any study with total confidence. Let's get to work.
Here's the game plan for today. We'll start off with the foundations, move into the ethics rules, crack open the experimental toolkit, and finally, wrap up with the non-experimental toolkit.
Module 1. Foundations. We're talking reliability and validity.
Okay, so you really need to nail the distinction between these two for your exams. Think of reliability simply as consistency. If I run this study over and over again, do I get the exact same outcome? If so, that's high reliability. Validity, though, that asks a much tougher question. Is your test genuinely accurate? Are you actually measuring what you set out to measure? You can have a highly reliable set of broken scales that consistently tell you the exact same wrong weight every morning. They're super reliable, but completely invalid.
Now, what about the actual tools inside your study? That's your internal validity. Does your depression questionnaire truly measure clinical depression, or is it just picking up on temporary everyday sadness? External validity is the flip side. Can you take what you found and confidently generalize it to the wider target population? And this links perfectly to the types of data you're collecting. Quantitative methods, the numbers and hard science, they give you fantastic objective reliability. But qualitative methods, like descriptive interviews, they give you incredibly rich detail at the cost of being way harder to replicate and generalize. It's a constant trade-off.
Moving right along to Module 2, the rules of the game. Let's talk ethics.
The 2014 BPS guidelines lay out 4 non-negotiable steps that essentially form your ultimate moral duty of care as a researcher. We're looking at respect for autonomy, scientific integrity, social responsibility, and maximizing benefit while minimizing harm. Basically, you have to respect cultural differences, ensure you aren't making wild or misleading claims, provide actual value to communities, and above all, carefully balance the risks against the benefits of your studies.
Now, informed consent sounds easy on paper, right? In a lab, sure, you just hand them a form. But imagine observing people out in everyday life in a naturalistic setting. Gaining that consent upfront becomes a massive headache. You still have to be deeply sensitive to their privacy and cultural beliefs, even if you literally can't get that signature right then and there.
And hey, sometimes telling the complete truth right away ruins the entire study. That's just how it is. So, psychologists sometimes have to get a little deceptive. But listen, if you have to lie in the name of science, you are absolutely required to fully debrief your participants afterwards. You have to explain the real aims and make absolutely sure they're completely fine once the dust settles.
Alongside debriefing, we've got confidentiality and the right to withdraw. Nobody should ever be identifiable from your published research, period. And even more critically, you can never, ever bribe participants or offer them incentives just to stop them from using their right to withdraw. If they want to walk away, they can walk away and they take their data with them, no questions asked.
Ultimately, the whole shebang boils down to protection. You've got to protect participants from any physical or psychological harm they wouldn't normally face in their daily lives. And here's a massive evaluation point for your longer exam answers. Psychological harm is highly subjective. What's maybe just a mild annoyance to one person could be genuinely, deeply distressing to someone else. That makes predicting risk incredibly tricky.
All right, opening up Module 3, the experimental toolkit. It's time to establish some cause and effect.
The absolute best way to tell these experimental methods apart is to track the independent variable, or the IV. In a lab experiment, researchers tightly control the environment and directly manipulate that IV. Now, in a field experiment, you step out into a natural setting, but you're still the one manipulating the IV. A natural experiment is a bit different. It's in a real-life environment, but the IV is occurring naturally all on its own. You're just taking advantage of the situation to measure what happens.
Exam marks are won and lost on evaluations, so comparing these methods side by side is basically your cheat code. The strict control of a lab experiment makes establishing cause and effect super easy, but the cost? It's heavily reductionist. It totally ignores the messy reality of the actual world. A field experiment boosts that realism and drops demand characteristics, but bam, suddenly you've got uncontrolled extraneous variables muddying up your data. And a natural experiment? Peak realism, for sure, but you completely lose the power to randomly allocate your participants, which can lead to some serious bias.
Let's crack open our final drawer, Module 4, the non-experimental toolkit.
First up here, self-report techniques. We're looking at two very different beasts. On one side, face-to-face interviews. These can be structured with set questions, or unstructured, where you just build a rapport and really dig deep into a topic. On the flip side, we've got self-report questionnaires. These are your go-tos for rapid, large-scale data collection, and you don't even need an interviewer in the room.
Now, a massive trap to avoid in your exams is ignoring the specific types of questions when you're evaluating questionnaires. Yes, they're cheap, and yeah, they're highly ethical because getting consent is a breeze. But listen, while closed-ended questions are wonderfully objective and a dream to analyze mathematically, they really restrict what the participant can actually say. Open-ended questions fix that restriction entirely, but then boom, they become incredibly time-consuming and subjective to analyze.
Next, correlations. These are brilliant for showing how variables move together. Picture a scattergram. You can have positive correlations where both variables go up, negative ones where one goes up as the other goes down, or a zero correlation where it's just random dots, no pattern at all. This is a super cheap, highly ethical alternative when manipulating variables yourself would be, well, wrong. Like if you wanted to study aggression in a daycare, you definitely don't want to be the one causing that aggression.
If you take exactly one thing away about correlations today, make it this. They can show you a staggeringly strong mathematical relationship between two variables, but they can never, ever prove cause and effect. There could always be some unseen, sneaky third variable pulling the strings behind the scenes that you just haven't accounted for.
Moving on to case studies. By mixing up multiple methods, think interviews, tests, observations all rolled into one, case studies let us do a super in-depth deep dive into incredibly unique individuals or rare groups. This is absolutely essential for phenomenon you could never ethically recreate in a lab, like studying severe brain damage.
The data you get from a case study is fascinatingly rich. It often paves the way for completely new psychological theories. But there's a huge catch. The massive limitation you have to hammer home in your exam is the severe lack of external validity. You just cannot take the findings from one completely unique person and apply them to the general population. Plus, because they're one-offs, you can almost never replicate them to check for reliability. It's a real double-edged sword.
Finally, we have observation tools. This is just watching behavior unfold. You can do it naturalistically or in a controlled setting. It can be overt, where they know you're watching, or covert, where you're totally hidden. But whatever flavor you choose, you absolutely must clearly define your behavioral categories beforehand. If your categories are vague, you invite observer bias, and that will completely destroy the validity of your findings.
So, let's put all the pieces of this puzzle together. Think critically about this. If you were asked to study obedience in a bustling secondary school, which specific method from your new toolkit would you choose to perfectly balance external validity with BPS ethics? Would a natural experiment work best? A covert observation? And how on earth would you navigate informed consent? Knowing how to dynamically select and evaluate the right tool is the true key to totally crushing Paper 2. Think about it. And until next time, keep questioning the methods.